Yes, student, this is one of the very important type of physical equilibrium because here we will see some interesting thing. This is what? Gas solution equilibrium, or we can say gas liquid equilibrium. Okay, solution as well as we can also call it what? Liquid equilibrium. Okay, here the dissolution of gas in a liquid takes place under pressure but in a closed vessel. Always remember, whenever a gas involved in an equilibrium, it must take place only in the closed vessel. Getting? It is because it related to the partial pressure, and if there will be no closed vessel, then the pressure may be exchanged by system and with its surrounding. Therefore, it always takes place in a closed vessel. Student, you know that normally, that is at normal temperature and pressure, gases like O2 and CO2 spontaneously gets dissolved in a water. That is why there is an existence of aquatic animals or organism. Because how does the aquatic organisms are getting O2 and CO2? They are getting O2 and CO2 which remains dissolved in the water. So even at normal temperature and pressure, the gases are dissolved in what? Water. Here we are observing the rate of dissolution of gas in the given amount of liquid or solution is proportional to the partial pressure of gas. Means as more partial pressure of gas, more amount of gas can be dissolved in given amount of solvent. Student, the quantitative relationship between the dissolution of gas and its partial pressure, it is studied by a scientist Henry. Hence, according to Henry's law, the mass of gas dissolved in a given mass of solvent at any temperature or say constant temperature is directly proportional to the partial pressure of the gas. Okay, as much partial pressure, more will be the gas dissolved. Okay, above the solvent. Let m, small m, it is the mass of gas and T is its partial pressure. Then according to Henry's law, it's a very simple, mass is directly proportional to pressure, or m is equal to K into T. Here K is called Henry constant. Get it? In the similar way, if the solubility is given in the terms of mole fraction X, then equation 1 will become XA. That is what? Solubility of gas is equal to K into partial pressure of gas. Now, there is a great importance of Henry law, that is application of Henry law. First one, in the production of carbonated or aerated drink like Thumbs Up, Coca-Cola, Pepsi, etc. And one more application is in the deep sea diving. The diver uses a specific gas cylinder. Okay. Now, as the application is given in the production of carbonated or aerated drink. So, what is carbonated or aerated drink? Student, you have seen Thumbs Up bottle or Coca-Cola bottle, etc. Suppose this is a Thumbs Up or Coca-Cola bottle having vessel. Okay. You have observed that the bottle is only filled up to that amount of liquid solution. This is what? Liquid solution. Okay, and this is what? Thumbs up bottle. Say simply what? Thumbs up vessel. Now you have observed that the glass vessel is filled only up to that level. It is not filled up to the neck. What is the reason? Actually, student, we need carbon dioxide for chilling purpose in this aerated drink or beverage. Even in soda water, we need what? Carbon dioxide. Now the solubility of carbon dioxide at normal temperature is very less. I told you earlier. But if we have to add carbon dioxide in excess, then what we have to do? We have to fill the bottle, that is solution, under high pressure. Under high pressure. Why? Because according to Henry law, as greater the pressure, more amount of CO2 can be dissolved in it. More amount of CO2 can be dissolved in it. Are you getting? But what happens? Even when it is in high pressure, whenever gas, what? CO2 and CO2 of what? Solution, they remains in equilibrium. Means what? CO2 from outside and the CO2 from inside. This is what? CO2, which is already dissolved in the aerated ring. They remains in equilibrium, getting at constant temperature. Now what? Why do the bottle is not filled up to the neck? It is because when we bring out the glass vessel from the fridge and there will be high temperature in the atmosphere, then what will happen? You know that the solubility of gas is inversely proportional to the temperature. So what will happen? Already carbon dioxide is in under pressure. If the temperature will increase, then the CO2 which earlier dissolved in the solution will comes out. Okay, and therefore the bottle may be even burst or distort. Okay, so to check the problem, very first the bottle should not be filled up to the neck, one thing, and second thing, it must be stored in fridge or in cold place. Are you getting? One more important question is there, and practically you have observed it. As we open the bottle, the gas fizz out very fastly. Now that is what? Fizz out very rapidly. Why it happens? It is because the carbon dioxide gas is in under pressure. The external pressure is lesser as compared to the internal pressure. So if we open the cork, okay, immediately the pressure will tend to get balanced. That is external pressure and internal pressure. Okay, wants to become equal or balanced, and therefore the gas CO2 with liquid solution very fast fizz out with brisk effervescence. This is called with brisk effervescence. Or if you shake the bottle and open the cork, you will observe that gas as well as solution fizz out with very rapid speed. That is with very great speed. Getting? So these are the general observation. Student, it is very important topic. Often the questions are asked by this topic.